now let us write the function to test, write a program to test this function. Okay, and let me call this function as testing of the deep ReLU, right? So I'll call this as edit. Testing of this ReLU. So if you remember, our intention is to test the function for classification of digits, before which I need to specify what are the digits I want to classify or test, right? The same one will be used for the training as well. Okay, so that's our idea now. Okay, so let me just write down the same data which I will collect from test of batch. Okay, test digit, somewhere I have to have the digit, right? Okay, the multi-class one. Okay, I'll just copy this data. Okay, so x, starting from here, x and d. Okay, till here I'll copy because they correspond to the data set, right? So if you remember, the x of all rows, all column, first page is 1, then 2, 3, 4, and 5. These are the detections, right? So the desired values. Till here I can copy, right? From there. Now I have to define 4 different weights. So if you remember the weight, how to define the weights, just look at this. So this is 50 comma 25 inside this. It's 50 comma 25 because, right, there are 25 inputs, 50 outputs. So first you write the outputs, then you write the inputs. All right, so that's how we try to write it. Now let me do the same thing over here. Okay, so the weight W1 is equal to, this is 2 times random, right? If you recall the structure, there are 25 inputs and 20 outputs, correct? Because 20 neurons per hidden layer. So input has 25, so 20 outputs, 25 inputs, right? This is the only way which we follow, right? So I'll write to say minus maybe 0.75, random number, that's all. Okay, then W2 is equal to, this is say 3.5, make it as much random as possible, that's all. Okay, RAND into, look at the structure, right? There are 20 inputs, 20 outputs. So 20 outputs, 20 inputs, minus say 2.05. Okay, that is W2. All right, another weight W3 is equal to, say this is 1.75 into random values. How many inputs, how many output? If you remember, this layer also gets 20 inputs, 20 outputs. So 20 outputs, 20 inputs, minus 0.95. Okay, create another one. This is W4. Initial weight of that output layer is equal to, this is 4 times random. Now you see, output layer has only 5 neurons. So 5 as the output, 20 as the input, right? Minus say 3, 5. Okay, I initialized all the weights at random. Okay, after this, now let's go for the training process. So for the number of epoch equals to 1, 2, let me start with 1000 and check what's going to happen. What's the effect of increasing the weight? So training results in these updates, W1, W2, W3, and W4. All right, this is equal to, right? What is a function? Function name is deep array. deep ReLU of, so if you remember, the inputs are W1, W2, W3, W4. I have to pass the X, I have to pass the D. Okay, this updates the weights and finishes the training as many number of epochs as we specified. In this case, initially we started with 1000. So 1000 epochs will be there. So you get the updated weights. Okay, actually what we can do now is, right, we can say, we can even show the initial weights and we can show the final weights. Okay, so I can say uh, this initial weight equal to, okay, simply write, okay, I don't have to, okay, I just write this. Okay, I think this becomes too large because you see the size 20 to 25, there is no meaning in looking at the weights. Okay, so let me just skip that. Right, I can show you how to visualize if required. Okay, I'll do that later. Right, let's proceed further. Now, let me test. So this is start with the number of inputs, that number of classes or inputs, that is equal to 5 classes. Right, say for j is equal to all the input values, that is 1 till n, define x is equal to reshape, it is the x itself, capital X, sorry, capital X, from all the rows, all the columns, and jth page, right? Convert this into 25 comma 1, right? So that's my reshape. I perform the reshape, and now that's a X, right? Calculate the values. The partial output V1 is equal to, just see this is the same old procedure, so I'll go through quickly. So W into X, I get this thing, I obtain my actual output by passing this V1 through my value of V1. Once you have that, obtain V2 is equal to W2 into Y1. Okay, then obtain Y2 is equal to Y value of V2. Okay, get the output V3 is equal to W3 into Y2. Okay, then Y3 of V3. After Y3, I have to get the final value of V is equal to, this is W4 into Y3. Once you have that Y3 and V with you, you can calculate a final value Y. Y is equal to, now you see it is a softmax. Okay, my softmax of V. Right, finish. This actually creates the Y. Now we just have to verify whether we are able to classify or not. Okay, so let me save this first. Right, so now I have saved this. Let me run this and let me check what happens. So there is an error. says, oh, sorry about that. This is small letters, so I just have to update capital. Okay, now I think it should be fine. Let's let's look at a y now, because y is the class. Okay, right. Now let's do one thing. So I'll define what is called as a class equal to null. Then I'll do this. After this, the class is equal to class and append the y to this. And at the end, you ask to plot or give the class printed. Okay, now let's run this. See, no learning. It looks like there is no learning because everything is 0.2, 0.2, 0.2. Only in one case there is some learning, right? So now what we can do, increase the learning rate, right? Increase the number of epochs. Let's try that. So code is running, so it looks like pretty much fine for us. There is no error. Now let us see what's going to happen. No change. Increase further. If still there is no learning, it means I have some logical issue with my code. I have to update. Okay, so let's go back and check, is there any mistake? Okay, because after 10,000, is it 10,000? 1 lakh. 1 lakh iterations, I'm expecting some learning. Okay, so let me check. Let me start from my ReLU code. So what the ReLU has to do, it has to take an input. That input should be compared with 0. If it is less than 0, pass 0, otherwise pass x. So y is equal to max of 0 comma x. Yes, this is going to work fine, so no problem with this. Now let us move further. So my next is I just have to check my deep function. Okay, let's check the deep first. So we start with the pass the values, and for I is equal to perform x equal to reshape x, all rows, all columns, ith page, 25 comma 1. v1 is w1 into x, y1 is my ReLU of v1, v2 is w2 into y1. Okay, y2 is equal to my ReLU of v2, v3 is equal to w3 into y2. Okay, y3 is equal to my ReLU of v3. That's fine. Then calculate y is equal to w4 into y3. Yes. So y is equal to my okay. See the problem, right? Could you identify the problem over here? I made a mistake. So my final output should be softmax, correct? Not red, right? So this is the problem. My softmax. I think M should be capital for me, right? I think that was the error. Right, see, it's very crucial. Only one layer I missed, right? Final layer, instead of the softmax function, I simply used this. That is a problem. You see, all are giving the same values. That's because of that. I should have identified that time only, because if you are not getting one of the value high and all other values are 0, lower value, it means there is some error is there in the final layer, right? That's what is the use of softmax, if you remember. Okay, let me come back. Now I guess this should work. Again, let me start from the smallest possible value, just to check that from where it starts learning accurately. Okay, so the first is proper. It is classified as 1. Others you can see 0. But the second and third digits are not classified. Fourth digit is classified. Okay, and the fifth digit is once again not classified. All right, let's increase and see. Make it 10,000. Okay, now again we have, right? Not learning. Let's move further. I'm expecting something to happen. One, okay, second, third, fourth, fifth are not being learned. Again, that means there is some problem. Let's go back and check. All right. Okay, till there in the deep ReLU, we could check till the y value. Let me go ahead. I think should be some other mistake. Okay, so we calculate the desired value is equal to d of ith row, all the columns take a transpose. Error is equal to desired minus the y. Okay, delta is equal to e. That's fine. Then calculate E3 is equal to W4 transpose into delta. Delta 3 is equal to V3 greater than 0 dot star E3. That's fine. E2 is equal to W3 transpose into delta 3. Delta 2 is equal to V2 greater than 0 dot star E2. Yes, this is right. E1 is equal to W2 transpose into the delta 2. Delta 1 is equal to V1 greater than 0 dot star E1. This looks fine. Right, then we have the updation happening. dw4 is equal to alpha into delta into y3 dash. w4 is equal to w4 plus dw. Okay, dw3 is equal to alpha into delta 3 into y2 dash. w3 is w plus, this is fine. dw2 is alpha into delta 2 into y1 dash. w2 is equal to w2 plus dw. dw1 is equal to alpha into delta 1 into x dash. w1 equals to w1 plus dw1. Alright, this looks pretty much fine. And let's go ahead and check. Let me check this one. So I start with the zeros of 5. This is 1. Then the 2. Okay, then we have 3, 4, and the 5 written very properly. This is fine. Then we have the classes required this way. Alright, then we define the weight. Okay, W1, W2, W3, W4 is deep ReLU of all the numbers. Okay, that's also looks very fun. N is equal to 5, K is 1 to N, X is equal to reshape of, okay, X of all rows, all column, jth row, jth page 25, comma 1. V1 is W1X, Y1 is my ReLU of V1. V2 is equal to W2 into Y1, Y2 is equal to my ReLU of V2. V3 is W3 into Y2, Y3 is my ReLU of V3. V is equal to W4 into Y3. Y is equal to my softmax of V. Looks pretty much fun. Okay, let's try one more time. Maybe. Clears all. Everything is clear. That's not happening. Okay, let me run this. Oh, none of them is so. Okay, I think alpha value is very small. Let me increase this to 0.5. Right, let's check now. Maybe could be that's also one reason. Oh, class is not enough. points, then this cannot be, let's say 0.5. Now everything comes up. Or let me reduce the weight, say W1. Okay, I don't remember, I checked the weight. Weight is 20, comma 25, because 25 inputs, 20 outputs in the first one, 20, 20 in the second, 20, 20 in the third, 520 in the fourth. No, it's correct. Okay, let me make everything same and check. I don't know. This should not happen, but let's just follow this reference. I'll try to make it simple. Okay, I'll make let's say 2 into n minus 1. So let me make this also 2 into n minus 1. So all weights are different now, but they are generated randomly. But the method of generation of this random number remains same. That's all. Okay, they are still random. Okay, let me go to the ReLU and let me make it as 0.1. Yeah, first and the fourth class are getting classified, but not the other. It's defined. Look at the softmax. Softmax is that's correct. No mistake. There should not be a mistake as per this. Yeah. All right. Let's see somehow. Okay, so 0.9997, 0.9997 for first and the second, third, fourth, as well as fifth. Yeah, we are able to classify. Okay, so again, initialization of weight also matters, right? I think I brought too much of randomness over there. Maybe I tried to make it very simple, something very similar to all of them. So maybe that, I guess. Okay. All right. So that's the implementation of ReLU layer, right, as an activation function for the outputs of hidden layers. Okay, that was a one concept which we discussed. Then we also discussed about what is called as a dropout. Okay, so now let us try to write a code related to the dropout part. So, get it? So I want to write the dropout function. So what I try to write is dropout. Let the name be deep dropout. Okay, so it's a function. The inputs are, the outputs are updated weights according to the dropout. Okay, W1, W2, W3, W4 is equal to the name deep dropout of first variables W1, W2, W3, W4 input and the desired. Okay, right. Now, once again, I define the learning rate alpha equal to, let me keep the same value like previous one. Okay, I think we got 0.01 as the smallest value. Let's keep the same alpha. Then n equal to 5. Then for I is equal to 1 to n. Now, right, I'll collect my input x. Okay, x is equal to reshape, perform the reshape of which one? The x, right? All the rows, all the columns, ith page. Convert this into 25 rows and 1 columns. Okay, so that's the x. Alright. Then give this x as input, calculate the output, partial output v1, normal meter. So v1 is equal to the w1 into input x, correct? So I obtain v. Now calculate a y1 from there. So this is y1 is equal to which particular layer. I use a sigmoid. Okay, I just want to show you what happens with the if I include what is called as the dropout. I don't want to go with the ReLU. I will show you with the sigmoid itself. Later on we'll see, right, the other techniques. So I'll use my sigmoid of the V1. Okay, now you see I have an output, but I don't want all of them to be trained, right? What you use, I got a sigmoid output y1, but I drop out some of them. Okay, so y1 is equal to, let me say y1 dot star. See, I will call the function which is a dropout. Okay, I call my dropout. I have not written this yet. I'll write it later. Okay, so my dropout is a function which I'm going to write. What are the parameters I'll pass? I'll pass the values y1 and a percentage, right? 0.2. It's a 20%. Let me say I want to drop out 20%. So I call this. Are you okay? Right. Now my next step has to give this input uh, y1 to the next layer, which is y2. Okay, so you pass on this value, that is y2, y1 which you have with you, right? Calculate the partial output v2 by multiplying with the weights. Are you okay? So let's do that. So that means let's multiply to get this. So v2 is equal to the w2 into y1. So anyway, the use of dropout has been shown here. The only thing is I just have to write the function later. All right, let's write that as a different function later, but let's finish this part of the this function first. Okay, so I have a v2 with me, right? Use this v2 to get the y2. So y2 is equal to, once again, my sigmoid of v2. Have v2, you got a y2. Now update the y2 by dropping something of it, some portion of it. So y2 is equal to the y2 dot star my dropout of y2 comma 0.2. Let's keep 0.2 first. In every layer, let me try to drop out 0.2, 20%, and see what's going to happen. Okay, later on we'll see uh, whether I can increase or decrease, or what's the result of increasing or decreasing the dropout percentage. Okay, right? Then I calculate the v3. So v3 is equal to w3 into y2. Then y2 is equal, not y2, sorry, this is y3 is equal to my sigmoid of v3. I got a y3 now. So update the y3 by dropping out some portion of it. So this is y3 is equal to y3 dot star my dropout of y3. Okay, yes. So next part, I got this. Now I'll use these to calculate my final value of the output. That is, V is equal to W4 multiply W4 with the Y3. Okay, V is equal to W4 into Y3, and the Y is equal to, now you see it's output layer, so I have to use a softmax. Okay, no dropout here. This is because this is the final output, right? I cannot drop out anything, right? So get a Y, right? That is the softmax of Y. Now proceed further with the weight updation. So desired value is equal to the, in the capital D matrix, read ith row and all the columns, take a transpose for your for the mathematics of matrices. Then from desired value t, obtain the error e as difference d minus y. Once you have the d minus y with you, calculate a delta. In this case, delta equal to e, because you are using the entropy based cost functions. Okay, right. Then once I obtain the delta value, what is my next procedure? I have to calculate the errors of each of the layer, and I need to obtain from that, I need to update the weights. Okay, so let's do that now. So that means, okay, this part should remain very much similar with our test option. I'll directly go there and copy that. Okay, so deep ReLU, let me copy from here till the weight updates. Okay, paste it over here. Okay, let me just verify what we have written is correct or not. Is it applicable to this? Okay, so this is fine. So E3 is equal to W4 transpose into delta. Okay, delta 3 is a different one. It's not this because it's not ReLU, right? So if you remember, I have to substitute the value corresponding to the activation function which I'm using. The activation function I'm using is sigmoid. For a sigmoid, the delta calculation is, right, the Y3, this is just right here. So this is Y3 to Y3, you multiply, so it's a point by point multiplication. So Y3 dot star 1 minus Y3 into E3. Okay, see, because the function's derivative has to be written here, so phi dash of x has to be written here. Phi dash of, right, if the activation function is sigmoid, derivative is x into 1 minus x. So y3 into 1 minus y3. Same thing will happen. Okay, so this is y2 dot star 1 minus y2. Okay, then this also will change now. This is y1 dot star 1 minus y1. Okay, we got all the values, delta, delta 3, delta 2, delta 1. Then we go for dw4, which is alpha into delta into y3 dash. W4 is equal to W4 plus. This doesn't change. dw3 also will remain same so that it gets updated. So dw2 is also the same. Alpha into delta 2 into y1, and the last one also should remain same. That is dw1 is equal to alpha delta into x. dw1 is equal to this. Okay, now let's end the for loop and end the function. So that actually saves this function. Okay, now I know that I have used a sigmoid function which is predefined, but the dropout is not defined yet. Okay, so let me define my dropout function. Okay, so this is it my dropout. Sorry, drop off. Let me create this dropout. All right. Now I'm defining a function. I'm trying to return one single value. Okay, the single value is y. Y is equal to the name is my dropout. And what are the values you are passing? You are passing a value, say, okay, if I pass a value y, I don't want to return y. I'll call this as say y, maybe ym something. Okay, this is y, comma, you pass a ratio, right? So like 20%, something like that you pass. Okay, so now I have to use this, right? First, let me check the size. M comma n is equal to, I find out what is the size of y, because 20% of that I need to eliminate. Okay, so size of the y, right, which is an array. I try to find out the size. Then first I create the ym equal to, or keep all zeros of m rows and n columns, because m and n are the sizes of y. Okay, so I can use that to get the ym. Right, now you create a number. Number is equal to, it's a random number, so I'll create a it's a number round off, right? I multiply m into n into, see, this is how I create. I write 1 minus uh, maybe the ratio. I'll show you what exactly is going to happen, right? What exactly we are trying to do, I'll show. Okay, then after this, now I create an index. See, this is how I bring the randomness into picture. IDX is equal to, it's a random permutation. We have used this function, right, when we studied the basics of MATLAB. Okay, so RANDPERM. Okay, so you can use help in MATLAB to look at the details if you want. Okay, so this is m into, comma, I need the numbers. I use this numbers to get this. Okay, so get the index. Now only those index you create, right? Size is 1 comma sorry, size is m into n, right? And you put something like whatever number that has been generated, it will be located at those indices. Okay, that's all. So now it's a random permutation. Now I create ym of the IDX. All those indices will be updated with, right, 1 divided by 1 minus ratio. Okay, at those values I have these numbers coming up and I return that. Okay, so the ym will go back. Okay, I can. Okay, right. So this is the function that is required for the dropout option. All right, now let us quickly write our test function for this whole concept, right? I want to test with by writing a code. So okay, let me call this as edit test deep dropout. It will open up another this thing. So I actually need the same data and the weights. So I'll start copying from here all the way till here. Okay, let me see. just paste this. Let me check, is it right? So I have now clearing up x. I try to define x, and x of 1 is 1, 2, 3, 4, 5, as well as I define the desired values, and I have the weight. Fine, 20, 25, 20, 20, 25. Okay, that's fine. Then next one. Okay, let's proceed further. Now what I have to do, I have to train now. Okay, so for epoch is equal to starting from 1 till 1000, right? Outputs w1, w2, w3, w4 has to be equal to which function you are going to call. It's my dropout. Call that function. Is it my dropout? Just a second. I think I misnamed it. It's not my dropout. It has to be deep dropout. Okay, because deep dropout is a function which performs the deep learning using dropout. Deep dropout of pass the required variables. What are they? W1, W2, W3, W4. After W4, you pass the training vector X and the desired D. Okay, that finishes the training part. Okay, once that is done, now I need to go for the testing part, right? So testing part begins with the definition of n is equal to 5, n equal to 5 for j is equal to 1 to capital N. What I'll do, I'll take x is equal to perform reshaping option. So reshaping of capital X, right, in which all rows, all columns, and the jth particular page, comma 25, comma 1. All right, so that actually converts X into 25 data points, 25 into 1 vector, right? So V1 is equal to how to calculate W1 into the input, that is X. So since we are using the sigmoid function, so Y1 is equal to, it is my sigmoid of V1. So you have V1, calculate V2. V2 is equal to W2, multiply W2 with Y1. Okay, and obtain Y2 is equal to my sigmoid of V2. Okay, then we have V3 is equal to W3 into Y2, and Y3 equals to my sigmoid of V3. Okay, once you have that, we'll go for the final layers partial output, that is V is equal to W4 into Y3. You have this, and calculate the final output. Y is equal to which function? I cannot use sigmoid. I want only one of the output should be high, so softmax. Of V. Okay. Okay. I think this will be okay. So let's write the class once again. Class is equal to class is equal to class space y. After this, print the class on the display. Okay, let's try to run this. Okay, some mistake. Use of bracket line number 8. Y1 equal to Y1 star 49. My dropout of Y1 is in my check distance. Y1 equal to Y. Mismatched characters. My sigmoid of V1 gets into Y1. My dropout of Y1 with 20%, multiply that with the Y1 to get the Y1. It's correct. Let me check the function once again. So my dropout, what I'm doing inside the my m comma n, size of that variable which comes in. Ym is equal to zeros, num is equal to found, n. This looks pretty much fine. Alright, let's see. Let's check. It's a random one. My mistake. There's a D missing. Okay, now let's see. Round m into n into 1 minus ratio and y3 is equal to y3. Okay, y3. I missed this 0.2. Okay, I didn't give enough number of inputs. That's why just threw an error. Sorry, just a typing error. It should run. All right, now it's running. Let's see. So I'm training how many times? The epochs are less, I guess, just 1,000. So there is a lot of confusion. Okay, you can see that none of them is properly classified, but there is highest value for first class, here second class, here the third data, the fourth data, right? And in the last one, I think this is the highest, 0.27, but still you can see other classes are also very much high uh, percentage. So let's increase this 10,000 and let's run. Yeah, so you can see it's learning, right? 10,000 epochs machine has learned. Right, let's increase this further and let's make it 10,000 and let's check what's going to happen. Yeah, you can see one all are ones. Right, so the dropout actually has made the algorithm to learn quickly with lesser number of calculations, because since we though you left the neurons, right, 20% of the neurons in each of the layer you left it out, there is no training happening always, right? Even though that's the case, you see with lesser number of calculation you could train the machine, right? So the dropout is one very important concept, and even the ReLU, which we studied earlier, that's also very important here. We can actually hybridize this. My intention was to teach you how these things work, right? Definitely, you can try to write a different code which implements both the ReLU as well as a dropout. You can club together. Definitely, that will be much more efficient. Okay, so I leave that part as a assignment for you. You can take your own time. You can try to write that code, and if you have any doubt, you can contact.